Hello again. We are drawing to a close of our fraction unit, and we're talking about fractions and word problems. So here's where things get fun. No, seriously, it's going to be fun. We're going to review naming area and set models, comparing fractions and equivalent fractions. Let's get started. On this one here, it just asks us to add lines to make the parts equal, and what fraction is shaded. Here we can extend this line, and again we're going to pretend that I can draw these lines perfectly straight, right? Okay, so here we go. Now how many parts do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8 parts. So we know our denominator is going to be 8. And how many of those pieces are shaded? Just 1. Even though we have the number 2 in there, it's just to count how many pieces in total. 1 of the pieces out of 8 are shaded. How about this one? Here we have what looks like one of the rectangles cut in half, so we're going to cut the rest of the rectangles in half to make them equal pieces. If you imagine that you're sharing this and you want an equal piece to everyone else, then you want to make sure that all the pieces are the same size. So let's count how many we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So our denominator is 11. We have 11 pieces in total. How many are shaded? We have 1, 2, 3 pieces that are shaded. So 3/11 is our fraction there. In C, we've got a cool geometric design here, square inside a square. But if you see, we have triangles here. So you have to figure out how to draw triangles inside of this square. If we drew a straight line, and again, pretend it's straight line this way, then we can see that the two triangles with stars there are the same size. So now we have pieces that are all the same size. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces in total. And how much is shaded? Again, we've got 1/8 shaded. So notice that even though A and C have different arrangements and different sizes, different shapes and everything, because they're divided into 8 equal pieces, the fractions are the same, right? 8 equal pieces, one of those pieces shaded. Okay, let's look at D. D is a little bit more complicated because we have to divide it this way to show that we have even rectangles, but we also have to divide it this way to show that this rectangle is the same as this rectangle, the ones on the bottom there. But then we've got those rectangles divided in half by a diagonal line. So right there. And that gives us our equal pieces. So now count how many there are. 1, 2, 3, 4, 5, 6, 7, 8. Again, we've got 8 pieces. All the same size. How many are shaded? 1, 2, and 3 pieces that are shaded. So this one is 3/8. On this one, create a set of 5 shapes that are circles and squares such that 3/5 are squared. So we want 5 total shapes, and 3 of those shapes are squares. Now instead of having to draw them, I pre-drew them for you to make them look nicer. So we've got a total of 5 shapes here. We've got 1, 2, 3, 4, 5 shapes. And 3 of them, this one, and this one, are squares. So 3/5 of the shapes are squares. In the second one, it says to draw 3/5 of the shapes are shaded. And remember, it still says to use circles and squares, but it doesn't say which ones have to be shaded. So let's see what's there. We still have 1, 2, 3, 4, 5 shapes, and 1, 2, 3 are shaded, and they are circles and squares. Here it's create a set of 5 shapes that are circles and squares such that 2/5 are big. So here we've got 1, 2, 3, 4, 5 shapes again, and 1, 2 that are big. Sometimes when we're using fractions, if we're talking about a fraction of a whole, then we want to make sure that they're the same size. If we're talking about a fraction of a set, then they don't necessarily have to be the same size. So that can be a bit confusing, so think about that. If you have questions about that, make sure that you ask. On this slide too, it's got another set of similar questions. Create a set of 5 shapes that are circles and squares such that 1/3 of the squares are big. So we've got 5 shapes. 1, 2, 3, 4, 5 shapes. We've got 3 squares. 1, 2, 3 squares. We're not concerned with the circles, so we can ignore the circles. So now we have 1 of the squares out of the 3 squares are big. Again, a little bit confusing, but think it through and it should make sense to you. In this one here, we want 2/3 of the squares to be shaded. We've got 1, 2, 3, 4, 5 shapes, and we've got 3 squares. We're not talking about the circles. 2 of those squares are shaded. And in the last one, we still want a set of 5 shapes that are circles and squares where no shaded shape is big. So think about what that might look like. We're going to have some small shapes, some big shapes, some shaded, some not shaded. So we have some big shapes. We still have 5 shapes, 1, 2, 3, 4, 5 here. We've got big shapes, but no shaded shape is big. Any shaded shape here is small. Here we got some fraction strips. So we're going back to fractions that are the same. So we have strips that are divided into 7 pieces here. 1, 2, 3, 4, 5, 6, 7. And we want to show that 3/7 is greater than 2/7. So all we need to do is shade in 3 pieces on the top to make 3/7 and 2 pieces on the bottom to show that 3/7 is greater than 2/7. This is different from the last one that we did that had sets of things. 3/7 here is showing a fraction strip. Looking at this one here, we've got a picture or a diagram, and they ask us to write as many equivalent fractions as we can using the picture. Well, let's start by counting how many dots we have here. We've got 1, 2, 3, 4, 5 dots in each row. We've got 1, 2, 3, 4 columns. So we know that 5 times 4 is going to equal 20. So in total, we have 20 dots. So let's start with our fractions out of 20. How many dots out of 20 are colored? Well, here we've got 4 and 8. So we could say 8 out of 20 dots are colored. If 8 out of 20 are shaded, how many are not shaded? 12 out of 20 are not shaded. We could also look at them as columns. So here we have 1, 2, 3, 4, 5 columns like we already counted. So if we're counting out of 5 columns, how many columns are shaded? 2. How many are not shaded? 3. Are there any other fractions that you can think of? That should be all of them, because if we look at the rows, we can't really count how many rows there are because part of each row is shaded. We could say 2 things out of 5 in each row are shaded, but that gives us the same fraction as we have over here. So these fractions look like the only ones that we could write from the picture, but then when we analyze these fractions further, if we take 8/20, we know that we can divide that by 2. So 8 divided by 2 would give us 4. 20 divided by 2 would give us 10. So 4/10 would also be. So if we divided this in half, here we've got 4 out of 10 would be shaded as well. If we do the same thing on the bottom, 12/20 divided by 2, 12 divided by 2 would be 6. 20 divided by 2 would be 10. So 6/10 would also be an equivalent fraction for the number of dots that are not shaded. In this one, it asks us to write a fraction equivalent to 2/3 that has an even denominator. Let's start by thinking about what the even numbers are, because when they ask for an even denominator, they're asking for an even number. So our even numbers would be 2, 4, 6, 8, 10, 12, and so on. We don't have to go much further, really. We could keep listing numbers, but we don't have to because it just asks for a fraction. Next step is to look at what we could multiply 3 by in order to get one of these numbers. 3 times something is 2. That doesn't work. 3 times something is 4, that doesn't work either. 3 times something is 6. We could use 6 because we know that 3 times 2 equals 6. So that works. 8 would not work. We can't multiply 3 by anything to get 8. 10 doesn't work. 12 would also work because we know that 3 times 4 equals 12. So if we multiply 3, notice that 2 and 4 are both even numbers. Multiply 3 by an even number, we will get an even number for the denominator. Let's pick 4, just because I like working with 4. So 2/3, multiply the bottom by 4. We know by now that whatever we do to the denominator, we need to do to the numerator. So 3 times 4 will be 12. 2 times 4 will be 8. So a fraction that's equivalent to 2/3 with an even denominator would be 8/12. And there are other ones that we could use, but this is just the one that we chose. Now with that understanding, you should be able to do page 42 in your workbook. And if you have any questions, feel free to contact your teacher. I'd be happy to help.